limits. Section 1.2, and we're trying to figure out what is all this limit business. So first off, some notation that we need to get used to. Limit as x approaches 2 of this particular f of x is going to give me a result, and this result is always a y value. So when we're trying to figure out these limits, either whether we're doing them using graphs or we're using algebraic methods, the answers to limit questions are always y values. We're always talking about an x value going someplace, getting close to some specific x value, and how that function is being affected, what the y values of that function are doing around that particular x value. So what we've got this time is we've got this f of x function. It's defined as 1 when the x values are bigger than 2, and negative 1 when the x values are smaller than or equal to 2. So when we come over here, this is obviously a split function, and that, of course, the split is taking place at the value where we're asking about the limit. And what you're going to find with limits is that kind of thing happens a lot because we're trying to figure out behavior of graphs. That's really the function of what limits do, is they tell us about the behavior of graphs on specific values. So here's what we've got. When we deal with limits, whether we do them graphically or algebraically, two questions that you always want to know. Do the two sides meet? If so, where? Those are the two questions, specifically graphically, that we're going to look at. Do the two sides meet? Or do the two sides, let's use meet. Do the two sides meet? If so, at what y value? So those are the two questions that kind of go along with every limit problem. So if we look at this one, as x approaches 2 from the left-hand side, it looks like these y values are headed toward whatever this looks like, -1 or a little -1 point something. They're headed toward that value. As the x's approach 2 from the right-hand side, it looks like the y values, well, they're kind of staying up here. Are they going to meet? Well, according to my two questions, are those two sides going to meet when around x equals 2? No, there's no chance. So if that happens, this answer becomes where is the y value where they meet? That y value does not exist. DNE, kind of get used to that. That limit is non-existent because those two sides don't come together. So when you're looking at my two questions that I have listed down here, make sure you do them in the order I have them listed, because if you're trying to figure out where and they don't come together, it's going to cause you some trouble. Second one. Now I want to kind of contrast this one. We don't have a picture for this one, but if we did, wait a minute, 2x plus 1, I know what that looks like as a graph. That would be a line that would have a slope of 2 and a y-intercept of 1. Well, let's think about this. We're talking in this case about limit as x approaches -1. X approaches -1. Well, -1 would be over in this vicinity somewhere. If I drew that graph right, I don't know if I drew it perfectly or not, but as x approaches -1, let's ask the questions again. Do the two sides meet? Boy, it sure looks like around x equals -1 that they would be headed toward the same location. So that looks like the answer to the first question would be yes, which means we're going to have an answer. We just need to figure out where it is. The fastest way to find that answer is if you can substitute the x value, in this case -1, into this function that we have listed, then do so. We call it direct substitution. And if you can do direct substitution, you should do direct substitution. So here, I'm going to end up with, whoops, I don't know, I've got this extra little thing here. 2 times -1 plus that 1 is going to give me a -1 for a y value. At -1, if I had drawn my picture properly, this line that I drew should have been, it appears, 2x plus 1 would go down to and over 1. Looks like that graph would come through like this, and when x equals -1, they would come together when y is -1. So what we found here is a contrast between the two graphs that you can see on this page. Problem number 1, the graphs were headed toward two different places, so the limit didn't exist. Problem number 2, the graphs are headed toward the same place, so the limit does exist. And when I come down and look at problem number 3, Well, this time you have to forgive my picture. My picture didn't turn out quite the way that I wanted it to. So here's I'm trying to make this axis look kind of like it's supposed to. So let's move this up just a little bit. Anyway, the idea here will be, if I go and I graph this thing, this is what's supposed to happen. This is supposed to be at the point x equals -1. There's supposed to be a hole in the graph at y equals -3. And there's supposed to be this extra little dot here when at y equals -2. So what we really have is what we're eventually going to call a removable discontinuity. You don't know what that means yet, but you will one day soon. Let me ask my questions again. This f of x that we can see in the function, the -1 that we're approaching, are the two sides headed toward the same place? Yeah, it looks like they are. Are they going to meet? No, not quite. There's like that cushion of a dot in between them, but they're headed toward the same place. Well, if they're headed toward the same place, that means my limit is going to exist. Where is it going to exist? If so, at what y value? Well, at the y value -3, that's the cushion that's keeping these two sides apart. That y value -3 is our result on this limit. Are the two sides coming together? Roman numeral 1 question, are the two sides coming together? Yes, which means I will have a solution. Roman numeral 2, at what y value? At y equals -3, there's my solution. So with graphs, so your question is going to be, what about that blue dot, Mr. Perkins? What do I do with that blue dot? Well, the truth is that blue dot has absolutely no effect on whether or not the limit exists. All right, last problem. This one, I don't have a graph, and I don't want to have a graph, so I'm going to try that method that I suggested before. If I can substitute, I will substitute ds, directly substitute. If I take 0 and plug it in, will I get a y value? 1 plus tangent of 0 over 0 squared plus 1. Well, tangent of 0 is 0, which leaves us the square root of 1 on the top. 0 plus 1 is 1, which leaves us a 1 on the bottom. That must mean that these two sides are going to come together, and they're going to come together at y equals 1.